Okay, today I'm going to show you some functions and how we look at them and think about maybe graphing them. So this is topic 9, additional problems. The first problem says to find a function, let f be a function defined by f of x is equal to 4x minus 3. And we're told to find f of 4. So remember, the 4 is just going to replace the x. It's our input. So it's 4 times whatever that input is minus 3. So 16 minus 3, or 13. The next question is find f of a quarter. So for this, we're just going to simply put in a quarter everywhere that there's an x. Again, this is just going to be our box holder. And now we're just going to perform the math. 4 times a quarter is 4 over 4, right? We multiply across. Or 1 minus 3, which is negative 2. Then we're asked to look at f of 0. Nothing happens because it's a 0 that's different in how we start. It just makes everything easier. We have f times 0 minus 3. So the answer, this is just 0. And the answer is minus 3. Then we're asked to look at f of a. So this is actually just a variable substitution. F of a minus 3. And finally, we're going to look at f of a plus 1. So this is 4, and what we're going to do is make sure that wherever there was an x, we're going to put a parenthesis. We're going to create a little box that we're going to put the a plus 1 in. So now this is 4a plus 4 minus 3, or 4a plus 1. F of t is equal to 2t squared divided by the square root of t minus 1. Okay, nothing weird here. We replaced x with a t. It's still just a placeholder. It's a box holder. Okay, so remember, you can think of this as 2, whatever the input is, squared over the square root of whatever that input is minus 1. Okay, we're calling it a t in this function, but it's whatever is in the argument of the function. So if we're going to look at f of 2, we're going to just say it's 2 times the quantity of 2 squared over the square root of 2 minus 1. This is 2 times 4 over the square root of 2 minus 1, which is just 1, and the square root of 1 is just 1. So in the numerator, we have 2 times 4, which is 8, and in the denominator, we just have 1. So our answer is f of 2 is 8. All right, the next one is f of a. So we're going to say this is 2 times the quantity squared, right? So we're going to put our a here, over the square root of a minus 1. This is just 2a squared over the square root of a minus 1. Really, there's nothing I can do for that one except substitute the letters. Okay, another one where we're substituting a combination of letters and numbers is f of x plus 1. So again, we're going to put 2 times the quantity x plus 1 squared over the square root of the quantity x plus 1. It's a good idea to put parentheses so that you don't, if you're totally clear on this topic, that's fine, but if you're trying to understand it, use parentheses everywhere that there is a variable in the original function, and that way you can substitute in. Okay, so now we just work out the algebra. This is 2 times, and we're going to square this. So it's going to be x plus 1 times x plus 1 over, and in the denominator we have x plus 1 minus 1. So 2 times, let's FOIL this out. We need to put parentheses because it's 2 times whatever this is, x squared plus x plus x plus 1 all over the square root of x. This is equal to 2x squared. Oh, actually, let's go one step. Let's simplify in here. Plus 2x plus 1 all over the square root of x. Now we'll distribute this 2, so we get 2x squared plus 4x plus 2 over the square root of x. And that's as far as we can go with this one. Okay, let's try one. The next one is f. Let's remind ourselves, since it's on the other screen, that f of t is 2t squared over the square root of t minus 1. And now we're being asked to find f of x minus 1. So this is 2 times x minus 1 squared all over the square root of x minus 1 minus 1. Okay, that whole thing's underneath the square root. And that is going to equal 2 times x minus 1 times x minus 1 in the numerator, and the square root of x minus 2 in the denominator. So this is equal to 2x squared minus x plus 1 all over the square root of x minus 2. And this is equal to 2x squared minus 2x times 2 minus 4x plus 2 over the square root of x minus 2. I did 2 steps in one. I added these 2 as minus 2x and I multiplied by 2. We're asked to let f be the function defined with this piecewise function. So let's look at this. This is f of x, and it's defined by x squared plus 1 when or if x is less than or equal to 0, and it's defined as the square root of x if x is greater than 0. And we put this big bracket to say we are now defining f of x over different regions of what the input values would be. So therefore, if we're asked to find f minus 3, we have to first of all say, okay, this is where my input is, and where is that in relation to this definition? Well, negative 3 is less than or equal to 0, so I need to use the upper definition for this function. So when x is less than or equal to 0, this function says take whatever your input is, square it, and add 1. So this is 9. Negative 3 times negative 3 is 9, plus 1, or 10. Okay, f of 0 is equals, this is x is less than or equal to 0. So we're going to still use the upper function here. And we're going to say it's 0 squared plus 1, which is just 1. And then we're asked to find f of 1. Well, if we look at f of 1, it's the square root of x. Because x is greater than 0, right? 1 is greater than 0. 1 is greater than 0. So we go to the square root of 1, which is 1. It's okay that we have the same height. Okay, the next problem is we're going to have another piecewise defined function, and we're going to try this again. This one's just a little more complicated. It's an f of x, and it's equal to negative a half x squared plus 3 if x is less than 1. And it's 2x squared plus 1 if x is greater than or equal to 1. So again, we have a situation where we have the function defined as one way with x is less than 1, and then at 1 it switches over to the second definition of the function. Please be aware that you're not required to have every single value of your x, possible x inputs defined. We could have had a gap. We could have said x less than 0 and x greater than or equal to 4 and had a gap where the function was not defined over some values of x. And that would have mean that those values of x are not in the domain. But in this case, we are covering the entire number line of what x could be, from negative infinity to positive infinity. So let's try calculating in here. F of negative 1. Well, negative 1 is certainly less than 0, which makes it definitely less than 1. So we're going to want to go and use the upper definition of the function. So let's put in negative. I'm just copying, and everywhere there's an x, I put parentheses, and then I put my input in. There we go. So we got that squared plus 3. So that's negative a half. Well, what's negative 1 squared? It's just 1 plus 3, right? A negative times a negative is a positive, and we're just squaring that. And so then now we get negative a half plus 3. Well, if we're going to have to add half and 3, let's convert this 3 to halves. So we're going to multiply by 2 over 2, right? A disguised form of 1, and we get 6 halves. So minus a half plus 6 halves, the bottoms match. Most people got this on the exam. So we put a 2 here, and we have a minus 1 plus 6, or 5 halves. Now if we look at f of 0, going back to our function definition, we see that our function, when x is 0, this is where I'm looking, when our function is 0, it's less, at 0 is less than 1, so once again we're in the upper definition of the function. Okay, so all we're going to do is copy that function over. Hold on, let me come down so I can see a little bit more. Okay, it's negative a half times 0 squared plus 3. And this is going to all be 0, because 0 times anything is 0. So the answer is just 3. And now we're asked to look at f of 1. Well, f of 1, where's that? F of 1 is actually right here. F of 1 is this part equal. So now we're going to say it's 2 times 1 squared plus 1. And that 1 squared is just 1. So this is 2 times 1 plus 1. And so this is equal to 3. Okay. And finally, we're asked what's f of 2. Oops, I think I had this wrong. Oops. This had to have been greater than, because we can't have two definitions for what the function would be for any value. So I just because I accidentally erased it. I accidentally wrote it wrong. So make sure you check that you are not overlapping any region of the x-axis. That's not allowed to be a function. So finally, let's go to the last one we're asked to do, which is f of 2. So going back to our function, we see that 2 is greater than or equal to 1. It's certainly greater than 2, so we're going to use the function definition 2x squared plus 1. Oops. Two x squared plus 1. And we're going to put a 2 in here. So now we have 2 times 4 plus 1. And that's 8 plus 1, which is 9. For this next set of problems, we're going to be looking at the domain and we're going to be looking at some functions and determining what their domain is. So for the first one, we're given f of x is equal to 7 minus x squared. Now the two things right now that we have been looking at as being possible drivers for domain restrictions are division by 0. So you want to ask, is there any division possible? It looks like there isn't. The other one we've been looking at is whenever there's a square root, because we know that if there's a square root or an even root, could be a quarter root, but we're probably going to be focusing more on square roots, that what's inside the square root has to be greater than or equal to 0. So this box, so the box has to be greater than or equal to 0. So when you look at a function and you have to find what the domain is, if it's a polynomial function, doesn't have any division, and it has no square roots, it's defined for all values of x. So the domain is negative infinity to infinity in interval notation. Okay. The next problem asks us to find the domain for when g of x is equal to 2x plus 1 over x minus 1. So we have a quotient relationship, so we need to look at this and say, okay, when is a denominator equal to 0? Because that's what we cannot have. We cannot divide by 0. So this is a situation where we're going to look at that. So we say x minus 1 cannot be 0. So now you solve that as if it was an equation, adding 1 to both sides, and we say x cannot equal 1. The numerator has no restrictions. It's just a straight out polynomial. So the domain is the set of all x such that x does not equal 1. Now if I were to put that on a number line, I would just put a 1 and an open circle, and everything else is okay. So now I can translate this to interval notation. This is negative infinity. I read this, I come down to 1. Because it's open, I put in parentheses the union of 1 to infinity. Oops. So the answer in set notation or in interval notation. Okay, the next problem, f of x is equal to the square root of x minus 5. Okay, there's no division by anything here, so we don't have to worry about division by 0, but we do have to worry about the square root. So what does the square root restriction tell us for the domain? That what's underneath the square root, the whole thing, has to be greater than or equal to 0. So now we have to solve this inequality. It's a linear inequality. So we solve it directly by adding 5, and we say it's when x is greater than or equal to 5. So this is, we're answering this in the positive. This is not the restriction. This is not what we cannot do. This is what we can do. We can put things that are greater than or equal to 0 in here. So the domain is a set of all x such that x is greater than or equal to 5. And if I wanted to do that in interval notation, I would just come over to 5, and I would put a solid dot, and I would be able to take all the points to the right. So this is just a graph of the domain. And now to translate that into interval notation, I'd say it's 5 to infinity. The solid dot comes down as a square bracket, and and an open parentheses on infinity, because you can never get there. Okay, so this is our solution for the domain of this function. Oops. The next problem is f of x equals x over x squared minus 4. Okay, here we have a rational function, so we know that we have an issue with the denominator. The denominator cannot equal 0. So what we have to do is find when the denominator equals 0. So we know that x squared minus 4 cannot equal 0. We're going to address this in the same way that we solve for the roots or find the zeros of an equation. We're going to, because of this exponent of 2, we're going to have to factor. So we can either use the quadratic formula, or we can remember that anytime you see x squared minus, or let me change that, a squared minus b squared, this is always a plus b times a minus b. So on the left-hand side here, we get x minus 2 times x plus 2 cannot equal 0. So x minus 2 cannot equal 0, or x plus 2 cannot equal 0. So that means x, if we add 2 to both sides, x cannot equal 2, or over here we're going to subtract 2 from both sides. We want to solve for x. X cannot equal negative 2. Okay, so in interval notation, or sorry, in set notation, the domain is the set of all x such that x does not equal plus or minus 2. And if we want to write that in interval notation, we're going to put that, you can either write it directly, or if you're still learning how to do this, we're going to put the two numbers, oops, this is a minus 2, this is a positive 2, and we're going to put open circles around them because they're the values that we cannot have. We can have any value for x in either direction go into this function. And the way we write this, how we convert this now to interval notations, we read across from left to right of what the values of x are. So this goes from negative infinity to negative 2. Because it's an open circle, we put a parentheses, union minus 2 to 2, again, open parentheses, because in both cases, and they always face each other, the union, everything after 2. Sorry, I erased a little more than I wanted to there. Okay, so here's our answer. For the next problem, we're going to be looking at a challenge problem. We need to find the domain of f of x when we have the square root of 1 minus x in the numerator, and in the denominator we have x squared minus 4. So this is a combination problem, and it requires that we address each piece and then put all the results together in a sign chart. So let's start with the numerator. So the numerator is a square root. So we need that what's underneath the square root symbol, the entire contents of what's underneath the square root symbol has to be greater than or equal to 0. Okay, so now we're going to solve this. You can add x to both sides, but I've noticed students seem to mix that up a lot. So let's keep x on the left. We're going to say this is negative x has to be greater than or equal to, subtracting 1 from both sides, negative 1. And now we're going to multiply both sides by negative 1 to get rid of this x, and that means we have to flip the inequality. If we multiply by negative 1 on both sides, we have to flip that inequality. So instead of being greater than, it's less than. Negative times negative x is less than positive 1. Now for the denominator, we have that the denominator cannot equal 0. So x squared minus 4 cannot equal 0. X plus 2 times x minus 2. We just solved this one in the previous problem. Cannot equal 0. So we know that x cannot equal negative 2 plus or minus 2. All right, so how do we put this as the denominator? Okay, so now we need to put all this information together. So we know if we do a number line and we have a 0, we have a 1, we have a 2, and we have a minus 2. All right, so we know that x cannot be plus or minus 2. So let's put open circles there. And we know that x has to be less than or equal to 1. So it can be equal to 1. So we're going to put a solid line at 1, and we're going to come over to the left, but we cannot overrun another restriction. So we can jump over it, so to speak, and we can say this is where our solution set, x is less than or equal to 1, but we have to jump over negative 2 because that is not allowed. Notice that we have we are not allowed to be over here. So this, according to this rule, is not allowed. Therefore, this restriction is included, if you will. It's also not allowed, so we don't care about that. So we're going to read this off now and write it in interval notation and set notation. So let's start out with interval notation, reading from left to right. This goes from negative infinity to negative 2, open parentheses, because that's an open circle, union, also rounded parentheses, because we're picking up on the other side of negative 2, going the other way, reading from left to right, we're going all the way to 1. But 1 is included, so this is a square bracket. So this is our solution for our domain for this function. If we wanted to write this in set notation, we could say it's the set of all x, such that x is less than or equal to 1 and x does not equal negative 2.